So hi, thank you for the nice introduction. My name is Mandy Schipke. I'm the CEO of NOVUM from Dresden. And first of all, I just want to tell you something about the company because we're not well known at the moment. That's because we're not that old. We're a very young company founded in 2014. 2015, we got the High-Tech Gründerfonds as our first investor. Hey, special effects. It is the most important investor for high-tech in Germany. In 2016, we got the chair of the energy cluster of the federal state of Saxony, which was an honor for a startup to be the chairman of this cluster, and we still are, and I'm thankful for it. In 2017, we became High-Tech Startup Europe. This was an honor too. And we got a 7-digit invest, and we are growing since then. In 2018, we got the Digital Energy Award by Google and Innogy and the Future Mobility Award by Volkswagen and a few other prizes I don't want to tell you about. And the question is why we got all of that. And the answer I just want to present you in a little video.
Batteries, an unknown species. They are used for any purpose imaginable. You just can't imagine our commercial life without them. And yet, everything we know about them is this. And it's not even a precise understanding. That's because until now, the state of charge is only scientifically estimated. Quite a predicament. Because nobody knows exactly how long a battery can be used, or when it will eventually stop working. This lack of information every day, right across all business sectors, costs a lot of money. NOVUM Smart Chargers change that. Thanks to patented technology, they are mobile battery labs and vet batteries thoroughly. They automatically collect all data needed to determine a battery's state of charge more precisely than ever. And not only that, they can even tell you when a battery will have to be replaced and can send this information. Regardless of the sector, regardless of the type of battery, NOVUM technology can be used anywhere. This technology reduces battery costs, optimizes operations, allows digital maintenance management, and makes new business models possible. So say goodbye to all of that and trust your batteries with NOVUM Smart Chargers.
Okay, so actually you know everything you need to know about NOVUM, but I want to take the opportunity to tell you a little bit more about the technique and the use cases. First of all, there's a problem all of us know. You see 20% load on your smartphone, and then the next second the screen does this. It was the phenomena we started thinking about batteries and why they are so unpredictable. And the problem is that until today, the state of charge is just scientifically estimated. There's no measurement method for the state of charge. You always have to calculate. And these calculations or estimations are up to 30% inaccurate, depending on the environmental conditions. And the older the battery gets, the more increases the inaccuracy. And to make it worse, in practical applications, like in your smartphone or other battery applications, there's no practical way to find these SOH, the state of health, or the battery wear, somewhere on the screen or something else. And the reason is there's no way to measure this. And if it isn't a problem with smartphones, imagine this would happen here. You are in the middle of a forest and the battery turns off, no charging point around, and you have to think how to go there without any battery rest load. And why we seldom see this is because all battery applications work with buffers in quality and in load. This means from the capacity of your battery, you usually just use this. And this you never use. It is just there just in case. And this means batteries are 20% larger than they should be, and therefore they cost much more as they could cost. And they remain 20% below their actual capacity. Think of e-mobility. It means 20% less range than you could use, just because you never know how much load is inside, and you need buffers to work with it. Second problem, the capacity of a battery lowers down. The older the battery goes, the smaller the capacity gets. And see, the buffer is still there, okay? Means 100% SOC at the beginning of a battery lifetime isn't 100% SOC some years later. But as a customer, you don't have a chance to see this. You never know how much capacity is there to use or how much range do I still have to use in e-mobility cases. That's why we thought we have to change that. And to be honest, we're not the only smart people in the world working on this problem. Many people work on this. But unlike the others, we don't do thousands of measurements with thousands of cell types in huge laboratories. We bring the laboratory into practical applications. Means we take a laboratory measurement method. It's called Electrochemical Impedance analysis. You can forget it afterwards, okay? I just wanted to tell you a little bit about this. It's very simple. You just send a little bit of current in over a specific frequency range, and then you get a voltage answer back. And then you get curves like this, and this curve represents every chemical behavior or state inside the battery. You can read it from here. But the effects of state of charge, state of health, or temperature are overlapping. So it is not so easy to just see it. I brought you a simple example. We have a new lithium-ion cell. It is this one. And then we used it 2 minutes in a very hard way, let me say it was a short circuit. And then you can see this lighter green one. You can see this bow has changed a lot. Here you can see the battery wear. And of course there are temperature effects in, and we can see battery wear after 2 minutes in this method. This method until now was very expensive and was in such huge boxes, 10 kilos plus. Imagine 10 kilos plus on your smartphone, doesn't make sense. Or 10,000 euro with your smartphone doesn't make sense. So we made it very small and cost effective, and we do this impedance spectroscopy directly with power electronics, for example, with chargers. Okay, there you can see a little bit about our know-how. It is hardware-based, of course. We can do this impedance analysis with the power electronics, but the main know-how is in the evaluation of these curves. Remember? I hope it goes back. If you have just these curves, you have to deliver the scientists with the charger to interpret them. So we digitalize these scientists and put them into the chargers as well. There's a lot of AI inside and a lot of battery know-how which works automatically, so you don't have to care. In the end, you get these informations about the battery. Interesting at the moment is just the green box. You see the state of charge, not based just on the voltage, but based on the real chemistry inside the battery. So it's much more reliable. You can see the state of health, means how much capacity I have to use. And I see some more information. I can see the current potential operating time, which means nothing more than the range. Here you see it in minutes. In e-mobility cases, you can have it there in kilometers as well. Okay, these two bars are very interesting because it gives the customer safety with using the batteries. It means how long can I use my battery before I have to replace it with a new one. These says the typical degradation point of a battery is defined as 80% of the capacity in comparison to the start capacity of a battery. This bar tells you how long you can use it until the 80% capacity, but most of the users don't need this 80% capacity. They can work with much slower capacity of batteries. This is something you can see here. Just to give you an example, imagine we have Grandma Miller. Grandma Miller just uses her e-car to go to the doctor. The doctor is 10 kilometers away. She just goes 10 kilometers there and 10 kilometers back, but her e-car have a range of, let's say, 100 kilometers. So if she would change the battery at 80% capacity, she would change it too early because she never needs 80 kilometers. She just needs 20 kilometers. That's why the charger tracks the user behavior with it. So that can tell you for each individual customer how long will your battery last. And another information included in this bar is how have I charged my battery. Now these two things are important. You can of course charge quickly, or if I know all the time the state of health of the battery, I know before the start of the charging process what this battery can take for a current without heating too much. So I can load according to the state of charge. Means at the beginning of a battery lifetime, you can take higher current, and the older it gets, you just slow down the current a little bit. Means you save battery wear from beginning on in your charging process. And because we can do this impedance analysis while ongoing operations, we can react on visible temperature increasing before the temperature is increasing too much. Means we're saving much more battery wear. In the end, you can save up to 20% battery lifetime by charging your battery like this, and it doesn't take so much longer. You can see it here. It is 30 minutes, and this is 10 minutes. This is an example from power tool applications. Okay. Now this, I have all the benefits at a glance. I told you already, you can have reliable SOC values, you can reliable SOH values, you have end-of-life forecasts, which is interesting especially for acceptance problems for customers. They are very much interested in, can I trust my batteries? How long can I use it? They don't want to have this fear, where's the next charging point? And if you know a lot about your batteries, then this fear lowers down. Okay, and we have reliable temperature values, of course, because from impedance analysis you get the inner temperature of a battery, not from a sensor from outside, you get the inner temperature. Means you can react faster. If you see a temperature increasing, could prevent some security issues. Not all, maybe, but maybe some. Okay, you can have this information local on the charger in form of LED. We can show you on a flashlight systems, for example, red, green, blue, or something like that, the state of your battery, and you can send this information remotely into a service center, for example. This could be interesting for service issues. So if you know that the batteries at your customer will reach their wear point in 4 weeks, let's say, then you can send new batteries to your customer before the olds fail. Okay, now I just want to tell you a little bit more about the practical implementation of the NOVUM system, who profits, manufacturers, operators, sharing concepts and batteries for rent in the cases of battery-operated devices, stationary batteries or electric vehicles. And I calculated one example for you just to show you a little bit more about the costs. I took this. How does it work to work together with NOVUM? First of all, you buy a NOVUM Smart Charger instead of your old charger because all of these scooters already have chargers. You replace it. It costs the same. And then you book about 70 euros, and then you book your software package on top. At the moment we have 3, package S, M and L, depending on which values you want to have and where you want to have it. Do you want it local? Do you want it sent remotely? And I calculated this example for you. Let's pretend this e-scooter manufacturer takes the software package M. Then it means 0.7 cent per watt of the charger. And per month, it would make €3.50. Sounds a little bit expensive, but it is not if we see this. You see left, the e-scooters have a warranty design about 3 years. So the battery has to work minimum 3 years. And it has to have a range of 100 kilometers minimum in 3 years. The battery included in this scooter right now would last 4 years in the quality wanted and could make 130 kilometers. The battery costs are 600 euros. The charger costs are 70 euros, and no more costs. With NOVUM, you can choose another battery to have the same range and the same lasting time before, but a cheaper one. So the new battery with NOVUM is calculated for 3.2 years. Because of the smoothly charging, it lasts a little bit more. But for safety issues, I would never take just 3-year battery. The range is about 110 kilometers, and the battery costs are much cheaper than the old battery. The charger costs are the same, and you pay a license fee to us, about 100 26 euros for 3 years. After these 3 years, you don't pay anything. And you save 64 euros per scooter. This makes around about 2 million for 30,000 scooters. It's a win-win for all of us. So, almost the end. If you have higher quantity of devices, then I'm sure you don't want to pay me a license fee every month. So we can talk about single license fees as well. I brought you 2 examples with me. In the power tools sector, we are about 60 cents. Then you build everything on your own. We give you the plans, you build it, you integrate the battery monitoring in your device, and you pay us just 60 cents per device. Or in the other sector, 1 cent per device. And I think it isn't too expensive, and I would like to work with a lot of you here. And if you want to see or know more about battery monitoring, then visit us please at booth E45.
Thank you very much, Mandy Schipke. Are there any questions from the audience right now? Okay, then let me have the first one. I think it's quite a unique product, especially here at the fair.
Yeah.
Can you maybe talk a little bit, who would you like to work with? Because it sounds like very promising for different opportunities.
Yeah, at the moment I showed you, we work with a lot of business sectors, but I'm very, very open-minded to get to know new use cases. For example, charging stations or something like that would be interesting for me. Unlike that, I'm interested in working together with everyone who wants to make its battery predictable or uses cheaper batteries or just wants to know more about the batteries. Would be pleased if you visit us at our booth.
Just a quick question. Is it more B2B or does it also work B2C?
We prefer B2B because at the moment we're just 17 people. So,
okay.
Yeah.
So I wish you best of luck. It sounds very promising and I hope to see you next year again.
Thank you.
If you have further questions, please go to booth E45 with the Saxony, Energy Saxony on top. Thank you very much again.
Thank you.